Hello students, how are you all? Welcome back to the lecture number 9 of current and electricity. Okay, so energy, yes. So energy consumption in a circuit. Why? How it will happen? Suppose you joining a simple circuit with a bulb, with a key and then a bulb over here. So while you're turning it on, the bulb is glowing. And that is how, from this cell, you are taking some energy, and that energy giving you some amount of heat and some amount of light energy. So how we will calculate that energy? Right now you will see that. So before starting, we need to learn that we know V equal to W by Q, potential difference, that is equal to work done by charge. Okay, second one, Ohm's law, V equal to IR, potential difference must be equal to the product of current and resistance. And the third one is current itself is the rate of flow of charges, that is charge by time. We need to learn these three only. Okay, we will start from this one. Let's say, okay, in V equal to W by Q, in V equal to W by Q, we need that work done. Why? Because work done is give you always the energy. So now next one, V is give you the Ohm's law, while you can write IR instead of V. Acha. In the another one, I am taking Q as it is over there. Now see the trick. You are multiplying that with T, that means time. While also you have to divide with another time. As you are multiplying this one, you have to divide, thus it get cancelled out together. Okay, after dividing with T over there, we can say it is nothing but the current. See, this one. Okay, after solving that together, you are getting I square RT, that is equal to W. It is only applicable for this kind of relation. While you have a battery of V volt, and in this you are using a resistance of R ohm, and due to flow of current I for T time, while it will pass through this resistance, it will consume some energy or it will do some work, and that is known as I square RT. You can also write E equal to I square RT. And from there we will learn the Joules Heat Law. So let's move on to that. So we just learned that W equal to I square RT. Think in a circuit. You connected a cell with this resistance. While you turning it on, the current is flowing through it. That is, I current is flowing through it. We know that V equal to IR according to the Ohm's law. But just simply think, in that circuit, resistance will block that current. So all that energy will be converted into heat energy mostly. We observe that light bulb which used by tungsten wire, that is highly resistive wire, while the current are not passing through it and very few current is passing through it, and that is why it is generating more heat. Also you can take the example for nichrome wire we use obviously for the heaters. Alright. So in this case, while the current is passing through it, in this case the resistance converting the all energy into heat energy. Alright, so we just learned W equal to I square RT. That means for time T, the flow of current is I through the resistance R. Okay, so we know that the heat energy is proportional to the work done. And if you make it equal, you need one factor, constant factor, that is capital J, known as the equivalent heat or Joules equivalent. Its name is Joules equivalent and its value is 4.2 Joule per calorie. Just remember it. Okay. So after putting W equal to JH in this equation, you are getting HJ equal to I square RT. Very simple one. And you need the amount of heat. So I am placing H in this side and rearranging that one. So you are getting I square RT divided by J. So we know that H equal to I square RT by J, and from here we will define the dependency of heat. So in the first one you can say that the heat is directly proportional to the square of current, while the resistance and the time are constant. First one. Second dependency, that the heat is directly proportional to the resistance while the passing current and the time t is constant. Finally, the heat is proportional to the time while the resistance and the passing current is constant. These three dependencies are there, and by combining this three dependency, you are getting this formula, and that is all about Joules heating law. So that's all for today. Don't forget to like, share and subscribe, and so goodbye.